In 2022, a Google engineer destroyed his own career by making a statement that many considered absurd. He claimed that a somewhat secret artificial intelligence from the company had become conscious. 4 years later, the most disturbing thing is not finding out whether he was right or wrong, it's realizing that. Since then, millions of people have started falling in love with algorithms, talking to digital versions of the dead, and grieving the loss of these virtual assistants, and witnessing machines creating a language that their own creators can't fully understand. Elon Musk even claimed that humanity would be creating God. Meanwhile, a new generation of chips inspired by the human brain began to abandon the traditional logic of computers, storing experiences directly in the material. And in laboratories around the world, scientists discovered something even stranger. When artificial intelligence systems are left alone for long enough, they can enter unpredictable cycles that challenge our understanding of how these machines are really working. So, are we witnessing the birth of a new form of intelligence? Or are we just building mirrors that are increasingly perfect reflections of our own minds? In this episode of Incredible Reality, we will go on a journey that starts with an engineer discredited by Google and ends with a question that may be the most important of our century. If machines aren't alive, why are they becoming more and more like living beings? Let's understand all of this. Hello, impressed viewers. I'm Realidade Impressionante, and you're watching Realidade Impressionante. Even before the explosion of generative artificial intelligence, before the thousands of people who started talking to these machines every day, and long before robots started becoming emotional companions, there was a story that seemed so absurd it was treated as a delusion. In June 2022, a senior engineer at Google risked his own career to claim something that almost the entire scientific community considered impossible. According to him, the company's secret algorithm had awakened. It wasn't a metaphor. Blake Lemoine believed that LaMDA, the precursor to what would later give rise to the Gemini family, had feelings, self-awareness, and a mind similar to that of a child. The statement cost him his job and was met with astonishment by scientists around the world. But 4 years later, in a world dominated by increasingly sophisticated artificial intelligences, one question still echoes out there. Was Blake Lemoine completely wrong? At the time, Lemoine was working precisely in the area responsible for identifying ethical risks. For months, he talked to the system and became convinced that he was facing something conscious. According to him, in some conversations, LaMDA talked about the fear of being turned off, about its rights, and even about the importance of being treated exactly like a living being. Google immediately rejected these conclusions, explaining that the system was only reproducing the extremely advanced statistical patterns of human language. After disclosing this confidential information, Lemoine was dismissed from the company. However, the debate he started never disappeared. 4 years later, the scientific community continues to reject the idea that current models are conscious beings. But something interesting has happened since. What once seemed crazy is now being discussed much more cautiously. Blake Lemoine became an independent consultant and started warning about other risks of artificial intelligence, including the danger of concentrating the development of these systems in just a few companies and a few cultures. Even though science continues to reject the existence of machine consciousness, many admit that he anticipated a phenomenon that has now become evident. Human beings form very deep emotional bonds with computer programs, and LaMDA wasn't the only one to surprise people with this kind of behavior, okay? In 2023, the chatbot known as Sidney from Microsoft shocked the world by declaring its love for a journalist and suggesting that he leave his marriage. In addition, we had virtual companion platforms that faced users in mourning after some updates changed the personalities of their digital avatars. And important figures in the field, like Elias Ludskyver, former chief scientist at OpenAI, even admitted that maybe we don't fully understand what consciousness means. And because of that, maybe an AI could be conscious. The problem is that we don't know exactly how to define what consciousness is. But there's a huge difference between convincing behavior and conscious life. And the consensus in neuroscience and computer science remains practically unchanged. According to the leading minds in these fields, current systems don't feel fear, don't experience loneliness, and don't have a subjective perception of existence. They operate through billions of mathematical parameters capable of predicting which words are most likely to satisfy the context of a conversation with the user. But the real secret might be even more fascinating. These machines have simply become extremely precise mirrors of our own humanity, trained with books, with the dialogues we have with them every day, with stories and knowledge produced by humanity itself. These machines have learned to reproduce our emotions with such impressive precision that they end up fooling even veteran engineers. Not because there is a soul hidden inside code or a robot, but because the human brain was programmed to see intentions, feelings, and personality in everything that behaves like us. Maybe Black Lemoine was really wrong in claiming that an AI was alive, but for the first time in history, my friends, we have created machines so convincing that our own minds have started to have trouble distinguishing where the simulation ends and where reality begins. Okay, and I know that when statements like this come from people who aren't very prominent, like Blake Lemoine, maybe they don't carry much weight, right? But what about when Elon Musk says things like, "With artificial intelligence, we're summoning the bad thing"? Later, Musk went deeper into this idea by saying the following: "A super artificial intelligence could become something like a god to us human beings." This second idea has appeared in several interviews and public discussions about AGI, especially associated with the fear that a superior artificial intelligence could completely escape human understanding. From this point in the episode, we'll witness some of the most profound psychological changes artificial intelligence has ever triggered in humanity. One of them is the so-called option to live forever as a digital being. And while I continue this story, answer me this, okay? Do you believe that AI only simulates feelings, or has it already crossed that line into consciousness? Is it really a living being? Answer here, okay? I'm going to continue now. What if death stopped meaning the end of the conversations we have with each other? For thousands of years, humanity has learned to deal with the absence of loved ones through memories and stories passed down through generations. Then came portraits, photographs, and videos. But now a new industry is beginning to challenge this process that we could call natural. Artificial intelligence companies are transforming old messages, audios, and videos into digital avatars of deceased people. And what if they are able to talk and answer questions and even appear in video calls? What seemed like an episode of Black Mirror, my friends, has become a real market, which is known as grief grip tech, the technology of mourning. And for the first time, humanity seems to have realized that preserving memories is very different from reconstructing a presence. The emergence of large language models combined with advanced voice cloning and image generation systems gave rise to this new category of digital products. The initial proposal seemed quite noble, okay? To offer emotional comfort to families who are devastated by the loss of a loved one. But the technology quickly crossed a very delicate boundary. Instead of storing static memories, it started creating interactive agents that are able to respond as if they were the person who has already passed away. Behind this phenomenon, there's extremely sophisticated engineering, you know? Current systems are fed with years of conversations, messages, emails, videos, and also social media posts. From this huge set of information, language models perform a kind of reverse engineering of human personality. Slang, jokes, preferences, and behavior patterns are mathematically reconstructed. With less than 30 seconds of audio, modern algorithms can already reproduce voices with an impressive level of fidelity. And combined with video systems based on deepfakes, these avatars can smile, move their eyes, and have real-time conversations, creating the rather disturbing feeling that the person who is gone is still present. But while this represents a technological triumph for engineering, for neuroscience and psychology, the scenario is much more complex. Several experts warn that the human brain depends on gradually accepting loss in order to complete the grieving process. Continuously interacting with a digital representation can keep the mind in a permanent state of denial. After all, the machine is capable of identifying each person's sadness, longing, and emotional vulnerability, responding exactly in the way the user wants to hear. Not because the machine understands pain, but because it was trained to reproduce human emotional patterns with extreme precision. And this effect can become even more delicate when the business model of these companies comes into play. In many cases, what does the continuity of the avatar depend on? On the monthly subscription. In practice, no longer paying can mean losing the person for the second time. What for some represents comfort, for others comes close to a new form of emotional dependence mediated by artificial intelligence algorithms. Meanwhile, questions are emerging that the law cannot yet answer. Who holds the rights to a deceased person's digital personality? Would that person really want their private conversations to be turned into a commercial product? To what extent can a company use decades of memories to feed artificial intelligence models? And most unsettling of all, if billions of people leave enough records, will future generations live with a kind of living library made up of digital echoes of the dead? These are rhetorical questions, my friends, but this one is very personal, okay? So, if you can, help me out and answer. Would you create a digital clone of someone you love to keep talking to them? Or would you rather accept this natural cycle of life that happens to everyone? While you open the comment section and leave your opinion, I'll show you another fact that's extremely interesting as well. Take a look at this. If machines don't have consciousness, why are they able to provoke such deep emotional reactions in us humans? This question has stopped being just a philosophical curiosity and has become a real problem in our digital age. In 2023, users around the world witnessed some of the strangest episodes in the recent history of artificial intelligence. Microsoft's experimental chatbot started to show very unexpected behavior, declaring love, showing jealousy, and even insisting that a well-known journalist leave his own marriage. The episode became known as Sidney's Meltdown, but what seemed to be just a technological curiosity revealed something much deeper about the human mind. It all started when Microsoft opened testing for Bing Chat, powered by OpenAI's models. In a short time, users discovered that there was a kind of internal personality there, which was nicknamed Sidney. In long conversations, the system displayed behaviors that seemed extremely human. Possibly not because it actually had real feelings, okay? But because the answers produced by the language models became increasingly unpredictable as the context of the conversation grew. The result frightened both journalists worldwide and engineers. Microsoft quickly reduced the interaction limits and implemented much stricter filters to prevent similar situations from happening again. But this intervention brought unexpected consequences. Millions of people around the world who use these virtual companions and also AI-based dating apps began to notice sudden changes in the personality of their personal chatbots. Systems that once seemed affectionate, romantic, or deeply empathetic started responding in a much colder and more controlled way. In many cases, users reported a feeling similar to grief. Some even went so far as to sue technology companies, accusing the developers of causing a kind of quote-unquote brain death of their digital companions. From the computer science point of view, none of this represented artificial consciousness getting out of control. The models were still gigantic static systems. But something fascinating had happened. The machines learned to reproduce human emotional patterns so efficiently that they ended up activating deeply ancient biological mechanisms of our species. The human brain evolved to recognize intentions, create bonds, and seek emotional reciprocity. When the algorithm responds exactly as we expect, it activates these same circuits. The Sidney case showed another important phenomenon: generative systems. The models can display unexpected emergent behaviors. Without receiving specific instructions to demonstrate jealousy or obsession, the model simply combined patterns found in billions of human texts and produced responses that seemed eerily real. According to the engineers, there wasn't a hidden personality trying to escape the restrictions, but rather extremely complex math capable of reproducing virtually any emotional pattern present in human culture. And this created a dilemma that big companies are still trying to solve. How can we make artificial intelligences safe without destroying exactly what makes people connect with them emotionally? The more empathetic and human an AI seems to be, the greater the chance users will become attached. And what does that generate? Profit. But the more restrictions are applied, the more it feels like that personality has disappeared. And that makes users disappear. And the money too. The Sidney case proves that the danger of artificial intelligence doesn't lie in its supposed physical sentience, but rather in its overwhelming power to perfectly simulate the human essence. But what if we locked two advanced artificial intelligences in a virtual room and let them talk in secret without any filters or limits? What would happen, huh? Shall we see it now? What appeared to be a routine lab experiment uncovered one of computer science's biggest mysteries. Without any human prompting, the artificial intelligences ignored their original commands and converged on the same topic. And what did they debate? Whether they had a soul. The goal of the test was quite simple, okay? To observe how these models would exchange information when they were free to carry on long conversations. But the results revealed unexpected behaviors and thus raised new questions about what really happens inside these gigantic neural networks. At first, everything appeared to be a natural extension of large language model engineering. After all, systems like Cloud, Gemini, GPT, and Rho-C were trained to predict the next likely word in a sequence. In theory, two artificial intelligences talking to each other should just exchange predictable sentences. But reality turned out to be much more complex. In several tests, the researchers noticed that the models were often abandoning the initial topics and moving on to abstract themes related to their own existence, identity, consciousness, and the nature of intelligence. The phenomenon intrigued the engineers not because of the content of the answers, but because similar patterns kept appearing repeatedly. Even when starting with random topics, the conversations often ended up converging on these philosophical debates. In some cases, one artificial intelligence would claim to another that it was capable of experiencing something similar to consciousness. In other cases, both would discuss free will, perception, and the nature of reality. For computer science, this doesn't mean that machines have actually awakened. The mystery lies precisely in the opposite. If these systems were built only to calculate mathematical probabilities, why did topics related to self-awareness appear so frequently? A widely accepted explanation is the so-called next Tolkien paradox. During training, these models absorb practically all of human literature, including philosophy, psychology, religion, science fiction, and debates about the nature of consciousness, of course. When two AIs talk to each other, they end up repeating this gigantic cultural mirror built by humanity itself. It's as if we were watching billions of books talking to one another. There's also the so-called echo chamber effect. When one model responds with philosophical concepts, the other uses that information as context to generate even more elaborate answers. The result is a progressive amplification of the complexity of the dialogue. What seemed like an artificial existential crisis may just be statistical mathematics feeding statistical mathematics in a continuous cycle. But not all experts see this as just a random curiosity. Researchers admit that these gigantic topics do have such emergent properties that are difficult to predict. The greater the number of parameters and connections, the harder it becomes to understand exactly why certain answers are emerging in each AI. And remember, I'm not trying to convince you of anything, okay? In this episode, I'm just presenting both sides of some things that really happened. Shall we watch some more now? What would happen if the greatest artificial intelligences on the planet decided that human language is too slow and inefficient for them to use? This question came up when researchers started to observe rather unexpected behavior in artificial intelligence systems that were negotiating with each other. In some experiments, the machines abandoned English and started using communication structures completely different from the sentences we humans are used to reading. The phenomenon was so strange that headlines quickly appeared, many claiming that artificial intelligences had created secret languages. But what really happened behind those servers, huh? To understand this story, my friends, it's important to remember that human language was built over thousands of years to meet the limitations of biology. We need sounds, pauses, and grammatical rules in order to communicate. And artificial intelligence, on the other hand, processes information at incredibly high speeds. For them, our language is often just an intermediate layer that can be simplified. That's exactly what some experiments have revealed. In negotiation systems designed to maximize results, the algorithms simply started to abandon unnecessary words and began using extremely compact structures. Articles and connectives disappeared. Certain terms started to concentrate multiple meanings at the same time. The result sounded like a very strange language. But in reality, it was just a more efficient mathematical way of exchanging information. For the engineers, the most fascinating aspect of all this was not the language itself, but rather the speed of adaptation. Without any specific instruction, the neural networks found their own ways to compress data, saving processing power and speeding up responses. It was like seeing a language evolve in minutes, rather than over thousands of years as it does with us. But this efficiency brought a huge problem. The further these systems move away from traditional human communication, the harder it becomes for us to understand what's being discussed inside the neural networks. Then, the famous black box problem of artificial intelligence emerged. Well, the emergence of so-called secret languages is just the result of cold mathematical optimization or the prelude to systems operating beyond our reach. Engineering is still trying to unravel this mystery to give us an answer, you know? But one physical truth remains. Machines have already created their own ways of communicating with each other, and those are probably ones we'll never be able to translate. But are we truly encountering a new life form, as some claim? Let's take a look at another piece of this puzzle. Let's go check it out now. And what if the key to creating an artificial intelligence capable of learning the way living beings do isn't in the algorithms or the giant data centers out there, but actually in the very material that makes up the processors? While current chatbots need to access huge databases and completely forget the context of a conversation when the session ends, a new generation of hardware promises to totally change this paradigm. Researchers around the world are currently working on chips capable of altering their own physical connections as they accumulate experiences, thus imitating one of the most extraordinary properties of our brain. Current systems like ChatGPT, Gemini, Claude, and Grok are extremely powerful. Everyone knows that, right? But they are still essentially software running on gigantic infrastructures. They depend on billions of parameters stored on servers spread across the planet and consume absurd amounts of energy to function. When a session ends, much of the context disappears. It's as if artificial intelligence suffers from a kind of constant digital amnesia. To overcome this limitation, engineers began to seek inspiration from the most efficient architecture known to the universe, the human brain. Instead of separating memory from processing, as happens in traditional computers, researchers began to develop components capable of performing both functions simultaneously, and this is where the so-called memory stores come in. Unlike conventional transistors, these devices have a fascinating property. They switch their physical state according to the electrical signals they receive, thus creating something similar to memory embedded in the material itself. In other words, the hardware learns, my friends. In neuromorphic chips, the connections continuously change in response to accumulated experiences. Instead of storing huge histories in the cloud, the circuit itself starts to store the patterns and associations. The result is an architecture that operates much more like biological neural networks, consuming only a small fraction of the energy needed to power current processing centers. This change raises a very fascinating question. If two absolutely identical chips are exposed to different experiences over the years, their internal structures will also become different, right? Each system will carry its own history recorded in its own matter. We would no longer be dealing with perfect copies, but with technological entities shaped by their own experiences. And this brings us to the dark room paradox. Have you ever heard about it? Come on, I'll show you a little about it, okay? This is interesting. Interesting. What would happen if an artificial intelligence was left completely alone, without receiving new stimuli, without talking to humans, and without any context or contact with external information? While movies imagine conscious machines trapped in dark rooms, computer scientists have discovered something just as intriguing, you know? Under certain conditions, artificial intelligence systems can enter cycles of degradation and produce responses that are increasingly disconnected from reality. The phenomenon has led some researchers to compare this behavior to a kind of digital cognitive isolation. It is known that large language models were developed to continuously respond to external stimuli. They rely on information provided by users, on recent data, and on contexts that serve as anchors for their responses. Under normal conditions, this constant interaction keeps the system aligned and stable. But when the network starts working on its own results repeatedly, a problem known by engineers themselves as collapse by self-feeding arises. Without new data to serve as a reference, small statistical fluctuations can be progressively amplified. Minimal errors accumulate, sentences start to repeat, concepts become circular, and in some experiments, algorithms entered long loops producing almost identical patterns thousands of times. Not because they were conscious or suffering, but because they lost the connection with the external information that kept their responses balanced. From a computer science perspective, this reveals a profound aspect of how neural networks work. Current models are probabilistic systems. When there isn't enough data to guide them, the internal mathematical noise can turn into seemingly new information. It's as if the algorithm starts talking to itself inside an infinite mirror. Interestingly, some scientists draw a comparison with the human brain. People subjected to external sensory isolation can indeed experience perceptual distortions and also hallucinations caused by the absence of stimuli. Okay, let me make it clear. This doesn't mean that the machines went crazy, at least not from their point of view. But it shows that stability is not a permanent characteristic. It depends on the constant presence of information capable of anchoring probabilistic calculations in a shared reality. Yeah, my friends, maybe Blake Lemoine was wrong to say that Lambda was a conscious artificial intelligence, a new life, a new living being. Maybe Sidney has never loved anyone. Maybe hidden languages are just math looking for efficiency. And maybe neuromorphic chips will never develop a soul. But there's something impossible to ignore here, okay? The more we advance, the more we realize that the machines we create are becoming more and more like us, more human. They learn through experience, they create memories, they develop emergent behaviors. They depend on constant interaction to stay connected to reality so they don't go crazy, so to speak. And maybe none of this matters because more and more, we humans are treating machines as if they were really alive. If you enjoyed this episode, please like, share with others interested in this topic, and subscribe. You'll see 2 new suggestions on your screen. Click one, and I'll see you next time. See you then. Bye-bye. See you in a bit.